Hi everyone, I'm Mikhail. Welcome to the Dark Wire Labs YouTube channel, where we break down network technologies and bring them to life with real code. Today, we are diving into captive portals for public Wi-Fi networks. We'll explore their architecture and walk through the step-by-step authentication flow, highlighting the role of each component: the client, the network device, the authentication server, and the web server running the captive portal. Finally, we'll build and test our own access control system to register and authenticate gated Wi-Fi users in a real lab environment. Let's get started. Captive portals are commonly found in public networks, on buses, trains, in shopping malls, restaurants, airports, and parks. They serve several purposes: authentication, verifying the identity of users before granting access; authorization, controlling which resources or services a user can access; registration, collecting basic user information before allowing connectivity; acceptance of terms, ensuring users agree to network policies and disclaimers. Key properties of a captive portals: traffic interception, so all user traffic is initially redirected to the portal page; access control, users cannot access the wider network until they complete the portal requirements; session management, users are often tracked by IP or MAC address to maintain temporary access; device awareness, some portals detect the client device type to improve user experience. And also I'd like to add that captive portals can be implemented on external servers, but also directly on access points, wireless controllers, routers, and so on. Captive portals act as a controlled gateway between users and the internet, allowing operators to enforce policies, gather analytics, or require consent before granting network access. Everyday examples of captive portals: free Wi-Fi on public transport or airplanes; guest Wi-Fi in coffee shops or fast food restaurants; campus or corporate guest networks. Now let's talk about the flow, how clients connect to guest networks. So here I identified several steps that take place before access is granted. As you can see in this slide, so first, client connects to the open network. The network device, in this case, wireless access point, wireless controller, or it could be even a network switch or a router. First, it tries to authenticate the client through MAC address against the Radius server, just to check if Radius server already has a record about this client. If that's a new client, Radius server will not know it, so it will respond with access reject. In this case, usually network device places the client in a restricted network, kind of an isolated network, and it redirects all HTTP or HTTPS traffic from this client to the web server for the captive portal. Usually network device will allow only DHCP and DNS traffic and block all the rest. So, how clients understand that it's redirected to a captive portal? Well, this functionality is built in operating systems. So if you look in the table on the right bottom, you'll see what URLs are used by each operating system, like Android, iOS or macOS, Windows, and Linux. So the idea is common. all operating system, they try to connect to a specific URL and they are expecting specific response. And if the response is different, it means there is a captive portal. Because if there was no internet connectivity and no connectivity, they would not get any response, right? Their connection will be timed out or reset. But in this case, they are getting HTTP response, but not the response they're expecting. In most cases, the network device that intercepts HTTP or HTTPS will reply with 300 code stating that this resource moved and that the client needs to connect to a different resource. Sometimes in some solutions, you may also see that device will manipulate DNS and they can change DNS response or provide different response to client, again, pointing to IP address of the web server with the captive portal. So what happened next? The client established HTTP or HTTPS connection to captive portal, and depending on the role of the captive portal, either the client is asked to enter credentials, right, to, for example, authenticate through Active Directory or some external identity source, or the client could be asked just to register name, email address, phone number, and for example, to get an SMS with verification code. In this case, web server will integrate with some external providers, so SMS gateways. Or in some cases, the only role of the captive portal is to display some message and make sure the client accepts the terms and conditions. So in any case, whether it was authentication, registration, eventually the web server will collect some information, right, from the form, and then it will talk to the Radius server, and it will inform the Radius server that this client should be authorized now to have full network access. So the last step would be for the Radius server, and in most cases this is just one single system which combines a web server and a Radius server. That's called access control system. This system just responds to the network device with change of authorization request, informing the network device that the client is now authorized full network access. And it can also include the new VLAN where authorized clients should reside, or choose some other action. But the purpose is to change access for the client and to permit network access for the client. So that's it about theory. Now let's move on to the coding part. Now it's time to implement our own captive portal. So we are going to use Python. I decided not to use any libraries that provide Radius server functionality, but just to build it from scratch. So there will be two components that we are going to implement. One is the Radius server, another one is the web server. The web server will provide a form for client registration, and the Radius server will implement only MAC address authentication. We are not going to implement AP, TLS, or something like this for simplicity purpose. So before looking at the code, let's go step by step to see for each component what it actually does. So the first component is Radius server. So the Radius server, I'm going to use Scapy Python library to intercept packets And that's for requests, and for replies we'll craft our own packets and send them out. So there are two scenarios. First of all, the radio server, it processes authentication requests. If MAC address is on authorization list, access is accepted. Otherwise, access is rejected, and the radios will send reply to the network device. The other component is the web server. So web server will be listening on port 8080. We are not going to implement HTTPS for simplicity, only HTTP. The web server will implement get and post methods. Get method will just display registration form, and the post method will actually run when client clicks on submit button in the registration form. So from this method, the server will send disconnection request to the network device. Disconnect request is similar to change of authorization request, but it's just easier to implement, because in real scenarios we could use change of authorization to move client to another VLAN, for example, right, from untrusted to trusted network. But in our scenario, we will only tell the network device to disconnect the client and re-authenticate it. And the idea is that after client is registered, the radio server will get its MAC address in the authorized list and will permit access. And of course, the third component, we are not going to implement it, but it's a mandatory component, the network device. That's a Wi-Fi access point, which is broadcasting guest SSID. So I set up one in my home lab. And what it does, so it broadcasts open SSID, and it authenticates clients through radio server using MAC address authentication. So it puts MAC address of the client in the username field. And if client is unauthenticated, then the device redirects all HTTP requests from this client to a captive portal and blocks other access, except DNS and DHCP. But if MAC address, if radio server permitted access, accepted access, then full access is granted to the client. And lastly, I need to say that my network device should be listening to connections from the radio server for disconnect requests, just to authorize clients that passed registration. There is one important thing I'd like to highlight before I move on to the code. When we implement this scenario, how do the web server know MAC address of the client? That's actually a tricky part. In real life situation, there could be a couple of options. One option is that our access control system, which actually includes the web server and the radio server, it also acts as a DHCP server. So it allocates IP addresses for guest clients, and because of that, it has mapping of IP address and MAC address for each guest client. Another option is to include MAC address in the HTTP request when the network device redirects it to the captive portal. Unfortunately, my home lab doesn't support it. So in my scenario, in this demonstration, I'm going for third option, because my lab is simple, and in my lab, my server, my authentication server and my web server that run on my home computer, they are in the same subnet as the guest clients. So because of that, I can simply check the ARP table on my computer and get MAC address of the client from the ARP table. And this is what I implemented inside the web server code. All right, let's move to the actual code. So here in the in this code, there are two parts. The first part is actually the web server, and the second part is the radio server. As usually, I asked help from ChatGPT to generate this code. I didn't split it in different modules or even different programs. For simplicity, I kept it all inside a single file. So what we see here, this is the web server, and this is the method for handling HTTP connections, GET requests. And what this method does, it just responds with the HTML page. It's a simple form with just title register, and it includes client MAC address here. Client MAC address is derived from this function. And as I explained earlier, we check ARP table on our local computer. Of course, that's just exceptional situation. In real life, you'll have to use other methods to figure out client's MAC address. Second method is the HTTP post method. It's when client clicks on submit button, the client's browser sends HTTP post request to the web server. So what we do here, we add MAC address of the client from the form in the authorized MACs list. And basically that's it. And just show a message that client has been registered. And as you can see, the server is running on port 8080. And this is part of the code corresponding to the radio server. So my radio server will be running on port UDP port 1812. I'm going to use the shared secret emitter just for fun, and this is IP address of my network device, authenticator. So what we have here, this function parses radius packets, and as I said earlier, we use Scapy library to parse individual IP packets. So we need to extract the data that is inside the radius. Then we need to craft a reply, and we'll reply either access accept or access reject. And third function is to send disconnect request, what is similar to change of authorization. So we'll send disconnect request to my network device to force the client to force the device to reconnect the client and re-authenticate it. All right. So that's the code, how Radius processes each request. Basically, we just get the MAC address of the client from the request, from the user field, from the username field, and we compare it against authorized MACs list. Yes, and we accept or reject. That's it. The program is pretty simple. So now let's try to run it. All right, so we see the radio server has started successfully. The web server has started as well. Now I'll do my test. I have my phone, and I'll try connecting it to the guest network. Just allow me some time. So this phone is not registered, and because of that, we are getting access reject by the radios. Let me show how the Wireshark capture look like. So that's my network device, my wireless access point that sent access request to the radio server. And if we go and look inside the Radius protocol here, we can see the username is actually the MAC address of my client. And we can also see some other parameters. All right, so, and we see that the Radius server replied with access reject because my client is not registered yet. Cool. So now let me just try it once again. Okay, and now I'm getting to the captive portal. Let me show you. I'm not sure if you can see it, but that's how this portal looks like on my phone. So it's showing my MAC address and it's offering me to click submit button to register. So I'm clicking and I'm registering. And now my authentication request is accepted. And I got full network access. Cool. Let me show you packet captures. So this is packet capture when my access was accepted. And if you look in the request, you'll see that the MAC address is the same, right? The only difference is that the Radius server now has my MAC address in authorized clients list, so it permits access. Unfortunately, I didn't capture the disconnect request, but it's still logged here. Suppose in the real life, your access control server will look differently. It will be more complex. And also sometimes it makes sense to run captive portal directly on the wireless controller on access point, because this simplifies process a lot, as you don't need to send change of authorization messages back to the network device. In this case, if the portal is hosted locally, it will use internal API to notify it that authorization of the client was changed. Of course, also in real life scenarios, you could even make these networks more secure, because if it's not a public network, but if it's an enterprise and their guest Wi-Fi, they may also wish to, for example, use AP, right, some additional layer of authentication. If you are interested, we can talk about it in our next videos. So I hope you enjoy this video. See you next time.